In this video, we discuss some more classifications of integral equation. The first classification is Fredholm integral equation of second kind. What does second kind means? And we already discussed in previous video that when there is a f, then it means that fixed limit. So we remember what does Fredholm integral equation means. But here we will talk about what is second kind mean. Second means two. So it means that integral equation is something where the two unknown appears. One is in integration and another one appears in the solution. Although these are one, but we try to understand, we try to memorize it by some trick. So there is one u, one, there is another u, which is two. So it means that it is called second kind. First kind means there is only one unknown. Example, here for you can see that we have kernel and there is only one unknown, and then we have x square. But remember that this is not second kind. This is first kind. This example somehow appear in first kind. But what when the limit is fixed, and that fixed limit actually tells us that this is Fredholm integral equation of first kind. So it should be Fredholm integral equation of first kind. It should be first kind since there is only one unknown that appears here. Okay. Similarly, you can see that this is also Fredholm integral equation of first kind. These examples should not appear in this section since we are talking about second kind. So it should be first kind. It should also be first kind. Now we move further and talk about Volterra integral equation of second kind. Second means there will be two solutions. There will be one solution, but two, it appears twice. This one is u, this one is u, so there are two u. And Volterra, why this is Volterra? Since the limit is variable. So this is Volterra integral equation of second kind. There is another classification of integral equation. It is called homogeneous Fredholm or Volterra integral equation. Homogeneous means that the source function f of x will be equal to 0. It means that this integral equation become homogeneous, similar to the differential equation when that differential equation becomes homogeneous. That equation become homogeneous when in differential equation become homogeneous when the right hand side or the right hand side becomes f of x. Okay, same is the case with integral equation. This is fixed limit, we have Volterra. This is variable limit, we have Fredholm. Next, we have Fredholm integral differential equation, which we already talked about that in our previous lecture. On the left hand side, we have derivative, and on the right hand side, we have integration. Since it is a combination of derivative and integration, that's why it is called integral differential equation. Similarly, we have Volterra integral differential equation. Volterra means V is variable, so there is a variable limit, which is upper limit. The variable limit can appear twice, maybe two times in the lower limit and the upper limit as well. So this is called Volterra integral differential equation. Next, we have linear integral equation. Sometime you may face some book or you may read some book. The title of the book can be linear integral equation. In linear integral equation, the unknown should appear with limit with power 1 with power 1. Okay, so and that operator is called linear operator. There can be a non-linear operator as well. So this is a linear operator. Here, for example, you see that this one is unknown. L has operated on U. So this equation becomes linear integral equation. If somehow there could be U square, then that equation, that integral equation is non-linear integral differential integral equation, not differential equation, but integral equation. Here you can see that we have fixed limits. So this is Fredholm, and you can see that there is only phi. And on the right hand side, we also have phi without any power. So uh, this is a Fredholm integral, linear integral equation. So this was all about the classification of Volterra and Fredholm integral equation of second kind. Thank you for watching.